Okay, this is question number 1. So we have this graph, this cubic has been drawn for us. Therefore, that's at 0, that's at -1, and that x-intercept is at 2. State the coordinates of the axial intercepts. Okay, the coordinates. So, -1 and 0, 0 and 0, and 2 and 0. Coordinates of the stationary points. So we've got 2 stationary points. So if I take this and I take its derivative, and set that equal to 0, and solve for x, so we get the coordinates, which are 1/3 minus √7 on 3 and something, and 1/3 plus √7 on 3 and something. So if we take our original and math 3 given x equals the one with the negative √7, and simplify that, I get 14 √7 minus 20, all on top of 27. And if I change that to a plus, I end up with minus 14 √7 minus 20, all on 27. Okay. Let g of x equal this. Find the values of x which f of x equals g of x. So if I take this expression here, put that into a new line, make it equal to x minus 2, and solve for x. And I get x equaling 2, or -1/2 minus √5 on 2, or -1/2 plus √5 on 2. Expression for the definite area gives the area of the regions bound by f and g. So I might want to have a little look at these. So I've got this region. So I've got 2 regions there. So this is the 2, and these are the 2 pluses and minuses. So the area is going to equal the integral that goes from here. Since that's 2, that has to be -1/2 minus √5 on 2 to -1/2 plus √5 on 2. And my top curve is f of x minus g of x dx plus the integral from -1/2 plus √5 on 2 to 2 of g of x minus f of x dx, and find the area. So I'm now going to do that on the calculator because I've got 2 decimal places up my sleeve. G-solve integral intersection points. I'll accept the first one. I'll jump over to the third one, and that will give me the area there, which is 5.94604, which is 5.95 square units. And in part D, 4 marks. So, f of x is x minus 2 x plus 1, and I want to add h to that. So this is my graph at the moment, and it's either going to be option 1 is I go down and I end up at this, and this will be A and this will be B, and that will be f of x minus the y coordinate of maximum, which over the page is this value here. So I'm looking for f of x minus 14 root 7 minus 20 over 27. If I make that equal to 0 and solve for x, that will give me a and b. So if I take this and I minus, that is, I bring this down to here. This is going to give me the a value because I know it's going to give me the b value. That's b and that's a, because b is the one that has got the bounce. So minus, I'll put up a bracket, and I've got this, except I've got a positive on the 14. And I go solve for x. And that gives me two answers for x. I know that the one on the left will be b. So that means b equals 1/3 minus root 7 on 3. And a equals 2 root 7 on 3 plus 1 on 3. That's one set of solutions. The other set of solutions is when we move up and make that my b, and that's going to be a, and that will be f of x plus, and that will be 14 root 7 plus 20 on 27. Make that equal 0 and solve for x. So I'm now going to come back up to the same answer and go plus, and it's going to be plus. And that gives me an answer of two answers. This is the one on the left, and the one on the left is a. So b equals 1/3 plus root 7 on 3, and a equals minus 2 root 7 on 3 plus 1/3, and they are the two possible answers for a and b.